Anyway, all right. We're recording, so we got to get started before the complainer complains. There's always one in every group. So I'm just going to go through. I'm doing this because sometimes I have to be contained, and sometimes I have to make sure I'm covering everything. So we're going to go quickly through the slideshow, and I'm going to say if it's important or not, and then we're going to finish up this review of Chapter 1 and Chapter 2 this week. Okay? So let's go ahead and next week. Let's see what it says. And I am recording. Yes. All right. Function. We talked about functions. We talked about the ice machine. We talked about that. We're not gonna. That's a function. Plug and chug. We're not gonna. We talked about plugging and chugging. We talked about points, and we talked about domain and range. The domain here is -5 to +5. But if it's not a curve, if you don't have a line between dots and dots, you have to list -5, -3, -1, 0, 3, and 5. That's the domain. The range is -7, -2. Well, the range is -7 to what? -6, but you'd say -7, -2, +5, +6. That would be your range. Your range would have four numbers: -7, -2, +5, and +6. So you wouldn't list all of these. You would just list those four numbers. Okay? And, okay, here is a very good test question. You'll see 3 or 4 of these on the test. What is the domain? Somebody tell me what the domain is.
-3 to 3.
Okay, I heard -3. That's good. That's the one. That's half the domain.
-3
to
3.
+3. And what is the range?
Close to -30 to
-30 to what?
40.
+40. Can y'all see that okay?
38. Looks like 30.
That's a 30 down there.
I'm not positive.
Can y'all not see it?
I was looking at the one on the bottom.
Oh.
Okay, let's talk about increasing. Increasing values. From -3 to looks like -1, close to -1. I don't know, maybe 1.25 right here. Let me get my handy dandy. I don't have my whiteboard pulled up. But right in here at 1 point, okay. Let me hit backspace there. Here we go. Well, okay, there's your domain and range. Increasing from -3 to -1.25, decreasing from -1.25 to 1, and then increasing from 1 to what? 1 to infinity. From -infinity to 1.25 negative, then from -1.25 decreasing to 1, looks like 1 or maybe 1.25, and then increasing from 1.25 to infinity. You're going to see that increase and decrease and show up here in a little bit, so you'll be ready for it. Okay? Okay, it's not infinity because it has, I'm sorry, it doesn't have arrows. I'm sorry. So negative, okay, I see what y'all are talking about. It's not -30, it's -27. My bad. To +39. Is that stupid? Yes, because usually on a test question, I would put it right on the 30 or the 40. I'm not going to sit here and make you guess. That's stupid. But anyway. All right, what about this one? This one has an arrow on the end of it. So the domain is -infinity to what?
4.
4. What's the range? 0 to what?
2.
Infinity.
0 to infinity because it has an arrow on the end of it. Okay. The y-intercept is 0, 2. All right, this is just, what's the domain? The domain is the years 1975 to what? 2015. And then the sales are the range, which is 0.04 to 1.22 or 122.0. I'm not really. Domain is the year, duh. Range is the cell. Some of these kind of insult your intelligence. All right, does the equation define as a function? All right, I want you to plot these two functions and tell me if they're domain. Tell me if they are a function or not. Then look at the domain and the range. So go ahead and plot those two characters. You're going to have to solve them for y. Solve the first one for y and see what you get. Tell me if it's a function using the vertical line test. Or you can use your calculator, whichever one you want to do. These are test questions. Every one of those graphs that we did, those are possible test questions. The one with the dot, the one with the arrows, those are all test questions. Let me turn my whiteboard on while y'all are doing that. Auburn looked pretty tough.
I didn't watch the
First one, I think.
I watched the second half of the Auburn game. I think Auburn's pretty tough because Washington's tough, but they're in the Pac-10, so they're not. You know, it's like the ACC. It's not that tough. Sorry,
That's like
but it's true.
the Pac-12, Pac-10, whatever. They're the worst conference.
It's right there with the ACC. I mean, I'm sorry. If it wasn't for Clemson and Florida State, the ACC would be a cupcake.
Now it ain't even Florida State. It's only Clemson.
And now it's not even Florida State, yeah. But Maryland did good, but Maryland's inconsistent. You don't know what's going to show up with Maryland.
Yeah. Well, Texas, you never know either. So
That's true.
that's what. Remember a couple years ago, or was it last year? Texas played like Notre Dame, and everybody thought it was going to be one of those teams was going to be real good, and both ended up being trash.
Yeah.
You never know. When the first game's of the season, you don't know. You don't know,
especially cupcake bowls.
Yep. Okay.
All right, so I'm going to take my handy-dandy whiteboard, and we're just going to plot these. And again, I do realize that most of y'all know this, okay? But I'm going over it for those that hadn't had algebra in 15,000 years. So, square root, take the square root of this side, take the square root of that side. So y is equal to the square root of 4x minus 4. We know that this is a square root function, so it's going to look something like this is the family it belongs to, right? Everybody knows that from your parent graph. But you have a negative 4, and that means a horizontal shift of 4 to the what? 4 to the right. Okay, and we'll get into that later. 1, 2, 3, 4. So that means it looks like this. So, domain, is it a function? Take your vertical line. Yes, it is a function. So your answer would be yes. Domain is 4 to infinity. Range is from 0 to infinity. What kind of graph is this? We know it's a parent graph of the parabola. The parent graph looks like this. Everybody with me? Look at your parent graph. Did we go over the parent graphs?
We did.
I got it. Yeah, I'm teaching a 110 and a 109, so you've got to remind me. Did we divide the sheet up into 8 sections? Okay. That's parent graph is a parabola. What does this minus mean? It means it's going the other way. Okay? It's going the other way, and it also is discombobulated because of the 6x. So what does it look like on your graph? Somebody graph it on your calculator. What does it look like? Let me see it. Because I don't want to. Yeah. So it's going to be going downward, and it's going to have some kind of look like this. Is it a function? Yes, it only crosses one time. Okay. Domain is negative infinity to what, 6? or I'm sorry, negative infinity, positive. You got two arrows. What's your domain if it's not a radical or a fraction? It's all real numbers. So infinity, negative infinity, positive infinity, and range is from negative infinity to what? Whatever that is, A. I'll just say A, because I don't know, it looks like about a 6 or something. But that question is basically asking, is it a function, yes or no? And both of them would be what? Yes.
Yes.
Good job.
See, it's not a solution, man.
So let's see what happens.
Give it to
The relation.
Ain't no relation function. Y is equal to square root of 4x minus 4. What did you get when you graph this? Y is equal to the square root of 4x minus 4. Did you not get a... Oh, they wanted the parabola, not the... Okay, I'm sorry. This is a hyperbola. I'm sorry. I thought they wanted to solve for x. I meant for y. I'm sorry. My mistake. But it should be the square root of 4x minus 4, but they don't want you to do the positive. They want you to do the whole thing, and that's why they got a hyperbola. So you need to... One of them is yes, and one of them is no. I don't think I would put that one on a test. Okay, let me go ahead and write this down. I will not put this on a test, okay? But I will put this on a test. You see what I'm saying? It's easier for you to see the function on a graph, especially when it's a hyperbola. I'm not going to try to trick you and say, okay, solve for y or not solve for y. The directions did not say whether you wanted the positive or the function. So I think that's kind of a trick question. So I would give you this. If I was to give you a hyperbola, I'll give it to you on a graph, not a function. Okay? All right, look at this function. Is it a function? Yes or no?
Yes.
Yeah.
Yes, it is a function. Now I want you to give me the domain and range. Now there's no arrows here. It's assumed to be arrows. So go ahead and put arrows on it. Okay? They're not asking for the domain and range, but I am. So put arrows on it. Draw a sketch of it for your notes. This is a test question. Okay? And of course, since it's not a radical or a rational, a fraction, then you have basically negative infinity to positive infinity as far as the domain. Okay? Negative infinity to positive infinity is also the range because you put in arrowheads. Now, let me ask you a quick question. This is kind of a review for those that have it in their brain. What is the min and the max? Or your vertexes? What are your vertexes? Well, your vertexes are your highest and your what? Lowest. So you got a vertex right in there, and you got a vertex right in there. I need you to make a note. That's your min and your max. Actually, your local min and your local max. Just make a note of that for later. Now, what did we say that f of negative 2 was? This is the pinky, but f of negative 2 back in pre-algebra was when x is equal to what? Negative 2, then you need to find what? If I give you negative 2 as x, you need to find what?
Y.
Y. So, find it. What is this? Negative 2. What is this? 4. So you can either use the graph or you can take those two numbers and do what? Plug and what? Plug and chug. I think you'll be able to find a decent number. What's negative 2? Negative 2 would be right in there. You're not going to be able to find it really graphing. I'm going to say 45. So I'm going to put a dot right. I'm going to put an approximate, which is a squiggly equals with a dot on it, which is I'm estimating around 45. Somebody take negative 2 and plug and chug into the function. Well, negative 2 to the third power is negative 8. Negative 8 times 2 is what? Negative 16. Negative 2 squared is what? 25 times 5 is 125. Negative 28 times 2 is positive what? 56. Somebody help me out. Minus 15. No hiccuping in class. All right, now add those four numbers up and tell me what you get. Make sure I did the math right. Somebody speak up if I made a mistake.
Plus, it's just negative 16 plus 20.
I thought it was supposed to be 20, not 125. Negative 2 squared is positive 4.
Okay, I don't know what I'm thinking of. I plugged in a 5. I'm sorry. I suck. It's the drugs I'm on. It's okay if I tell you I'm on drugs, right? The worse you are as a teacher, the better, right? So I'm on drugs and hungover. Because that's accepted now. If I'm a good person and I try to promote myself as a good person, I'm the Antichrist. So I'll just be a crappy teacher. All right, x squared, it'd be negative 2 squared is 4. 4 times 5 is what? 20. Is that what y'all got? Well, let's try that. All right, negative 16 plus 20 is what? 4. 4 plus 56 is 60. 60 minus 15 is what? It's a miracle. All right, so we put a 45 right here, and we feel good about ourselves, so we don't put smokestacks on our truck, especially if it's got a 4-cylinder engine in it. All right, 4. What are we going to do with that 4? Plug and chug, or we can look. Let's look. 4 is right here. Oh, I feel good about that one. I say 4 is equal to 80. Somebody plug it in and check. I'm not going to put an approximate here because I'm confident that's going to be 80 because of where it falls. Use your trace function on your calculator or plug it in. Tell me what you get. Heard somebody mumbling. Okay, it doesn't take that long. Trace function on your calculator shouldn't be. You can hit the window function and get 4. Come on. What'd you get? Okay. I got 81. Okay.
Yeah, I plugged it in 81.
Y'all got 81? Wow. That graph was a little bit misleading. Okay. So make sure you check it, plug and chug, or the best thing is to use your trace feature or your window. You know, your window, your table. I'm sorry. Hit table. What'd you get when you hit trace?
I got 80.
Okay. We got one person saying 81. We got one person saying 80. I need somebody to confirm. Well, let me just do it.
Oh, no, yeah.
What? Is it 81? Okay. All right, so that's a good test question. We're still reviewing, so you should be okay with that one. And that's 45. We done talked about that. The points on the graph give the number of elderly men in the workforce as a function of G for the year T for selected years from 1950 to 2050. Find and interpret G of 2020. That means plug in 2020, we get what? 21. Okay, that to me, that was. All right, what is the input If the output is y, if y is equal to, that's, take your pinky down, and that's y. When g of t is equal to 19.6, y is equal to 19.6. So if you're given y is equal to 19.6, let's take it back to pre-algebra. If you're given 19.6 is y, what are you going to find? You're going to find x. So y is equal to 19.6, which is 20. Now, you might have to put those points in the calculator and then draw the line and find the trace, or you use your window, okay? One of those two things. But I think we had a table a while ago, didn't we? Didn't we have a table with the years in it? You can put those in the calculator, and then you can trace it. But I get around 20 or 19.6. Looks like it's going to be 19. 1980, right? Somewhere around there. I'm going to say 1980.
2030 is 19.6.
That's on the x-axis.
Well, there's two that have 19.6.
He's
There's a
talking about the 19.6 on the x, like on the line. You see the third to the last?
Yeah, I see that. But there's two that have 19.6. In 2030 and 1980. But I might need to read the question better. Okay, 1950 to 2000. Looks like there's two if there's not. Let's see what they say. 1980 and 2030. 1980 was when Ronald Reagan was president. Let's see what they say. Well, they said 2030, but what about 1980? I guess 1980 just don't count. Does anybody see why 1980 doesn't count? I guess they're just looking for the dots and not the line. I guess you just disregard the lines and just go with the points. Like you said, 2030 is the only one that has 19.6. On a scale from 1 to 10, that's a 1 on the challenging. I mean, I don't like those two questions.
There's a lot of weird
I'm gonna move on. I'm not gonna insult your intelligence with those. I'm interested in the algebra. Plug and chug on those. All right, let's get to the next section, which is going to be 1.2. I'm just trying to keep everything organized, which I'm not. All right, here's where we get into. This is where we get into the family of graphs again. So, graph the equation y is equal to 2x squared. All right. First of all, which family of graphs is it in? It's in the parabola, right? So we take our handy-dandy black marker and we draw a graph of the parabola.
You have a work email.
Like that. That's the basic model. Now, when you have a 2, this is A. Remember, f of x is equal to ax squared plus bx plus c. Everybody write that down. That's the standard form of a quadratic. F of x is equal to ax squared plus bx. Somebody tell me what A tells us.
Oh, which direction?
If it's positive or negative, positive means it's going up or direction. A tells us direction and orientation. What do you mean orientation? Well, is it wide? Is it skinny? Is it opening upward or is it opening downward? Now let's write down these two things. If A is between 0 and 1, it's going to be wide. If A is greater than 1, it's going to be not wide. Compared to what? Compared to the basic model. What do you compare the Mustang GT to? You compare it to the basic Mustang. All right? What am I comparing 2x squared to? I'm comparing it to what? I'm comparing it to this guy. All right, we're going to take off from here in just a second. I want everybody to get out a sheet of paper in just a second, but I'm going to go ahead and I'm going to say that my graph of 2x squared is going to look something like this. Red, please. Is going to look something like that. Okay? Now, what I want everybody to do right now is get out a sheet of paper, and I want you to draw one big graph on this sheet of paper. This is where the colored pencils, the colored pens, and the highlighters come from. All right? I'm going to get a lot of chapter 2 in this section right here. What I want everybody to do, I'm going to take my handy dandy whiteboard, and we're going to go to the whiteboard. If I could ever get back on here. There we go. Whiteboard. I know whiteboard. And I want yours to be portrait. Okay, I can't turn mine to portrait. But I want to take a line and go across the page. Okay, let's try that again. I want to take a line and go across the page. And I want to take a line and go vertical. This is your page, only your page is portrait. I want you to label it. Label it as far as you can. 1, 2, 3, 4, 5 on all 4 axes. On the negative x-axis, the positive, all the negatives and positives. Go ahead and label them. Now do everything in pencil on the graph because, and the first thing I want you to graph it black or pencil. Then I want you to either get your highlighters out or get your colored pencils or get your whatever, the crayons or whatever, because I want you to do several graphs on this page. One, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the first one I want you to graph, in black or pencil. Y is equal to x squared. I just want you to do 5 points. -2, -1, 0, 1, and 2. I want you to plot those points. And I want you to take a straight edge, your driver's license or whatever, and I want you to connect those 5 points with a straight edge. I want you to do everything as accurate as possible because you're going to be doing a lot. There's going to be at least 4 or 5 graphs on this. So you need to make it presentable. And this is in the form y is equal to 1x squared plus 0x plus 0. So it's in that form. ax squared plus bx plus c. No coughing in class. I actually said that to one student complained to my boss. Said he won't let us cough in class. Whew, some of y'all need a sense of humor. You know, if we had better sense of humor, we wouldn't have crying closets and puppies to pet. Or what do you call it, a stuffed animal you get in the crying closet. Oh! I'm 51 years old and I've never been offended. Have I been called names? Yeah. My mom been called names? Yeah. I've heard drunk Irish all my life. Am I offended? No. I'm not Irish, I'm American. I have Irish ancestors, but that doesn't mean I'm Irish. I guess I am. I don't know. I'm offended. Drunk Irish, I'm offended. This is Guinness beer in this bottle. Because I'm a drunk Irishman.
Yeah, so I complain.
I actually can't stand Guinness beer. It's nasty. So if you graph this function, it's a basic function just like your other parent graphs. 0, 0, 1, 1, 1, 1, 2, 4. 2, 4. And if you want to, since I have a bigger graph, 3, 9, 4, 5, 6, 7, 8, 9, and 3, 9. All right, so that's what your graph looks like. Now, I want you to take a red marker or a pink marker or something in a red, orange, and I want you to do f of x is equal to 2x squared. F of x is equal to 2x squared plus 0x plus 0. Do the same points, -2, -1, 0, 1, and 2. And do it in a different color, please, because the whole point of this is we're going to see what's going on with all these numbers in front of these variables. Somebody's in the bottle, it sounds like. Keep hearing hiccup. Drunk Irish. Against me, they didn't say they're offended because of their nationality, and you ask them where they're from, they can't tell you. Where's your ancestors from? Oh, I don't know. I'm offended.
Sounds about right.
It's 3. Okay.
Just like now, everybody's racist now. No matter what you say, I'm a racist. Can't even I'm not even going there. I'm not even going there. Shut up, Hubert. -2 squared is 4, that's an 8. 1 is 2, 0, 2, and 8. So -2, +8. -1, +2. 0, 0, 2, 8, and, or 1, 8, sorry. 1, 8, and 2, whatever down there. Basically, what happens to the graph? It gets what? It gets thinner. Now, I want you to picture a rubber band, no, not a rubber band, a balloon that's filled with air, it's got a knot tied in it. Now, if I want that balloon to get skinnier than the black one, I need to stretch it along the what axis? The y-axis, right? Or I'll compress along the what?
X-axis.
X-axis. So you need to write that down. So I'm stretching. I don't even know how to spell stretching. Stretching along the y-axis like a balloon. You're pulling it apart like this along the y-axis, but I'm also compressing along the what?
Okay.
Or you can just say it's skinnier than the parent graph. All right, now I'm going to take the blue. You can take blue. You got a blue color, and I want you to graph y is equal to 1/2 x squared. Of course, if you had a decent algebra teacher, they would have told you -4, -2, 0, 2, and 4. What did I pick as points? Multiples of the what? Denominator, Hubert. That's right, class. So that way, I wouldn't have a fraction or a decimal. I'd have whole numbers for y. Well, my algebra teacher should have taught me that. Always, when you have a fraction, you always use multiples of the denominator. So that's going to be -4 squared is what? And this is like y, or f of x, is equal to 1/2 x squared plus 0x plus 0. So we're dealing with nothing but just a right now. And a has told us whether it's going to be skinnier, wider, or if it's going to be going in the negative direction. So what's 4 squared?
16.
And that's going to be 8. -2 squared, 4. 0, 2, 8. So -4 and 8. 1, 2, 3, 4. 2 and 2. 0, 0. 2 and 2. 4 and 8. And what happens? Well, now we're compressing along the what? So you're compressing along the what? The y-axis. And you're what? Along the x-axis.
Stretch.
You're stretching along the x-axis because basically you're getting wider. Stressing. I'm stressing. And that's a Freudian slip. Stretching. Ah! T-C-H-I-N-G. Stretching along the x-axis. Now, if you compress along the y-axis or stretch along the x-axis, you're going to have what? It's going to be wider, but you got to be more polished and refined. You can't say wider. You have to say it's compressing along the x-axis and stretching along the blah blah blah, whatever. It's getting wider. Okay, this one you got to be sophisticated and say it's stretching along the y-axis and compressing along the x-axis, or it's going to be what? 7. So what happens if take the green, dang old Verde, and f of x is equal to -2x squared plus 0x plus 0. So now somebody tell me what's going to happen before we even do it. Well, what is the red, what's the red parabola? The red parabola is what? 2x squared. So what is the green parabola going to look like? It's going to look just like the red parabola, except it's going to be what? And that's what A tells us. A tells us if it's going up, opening up, or opening down. It also tells us if it's going to be stretched or compressed along which axis. So it tells us orientation and direction. What about this one? And I'll do this one in some weird color, dang old magenta. And I just want you to tell me what you think is going to happen. What's that one going to be? Is it going to be wider or skinnier than the black parabola? You got a 50-50 shot. It's going to be skinnier. Remember, A between 0 and 1 is going to be wider. Well, Hubert, that's a fraction. Yeah, but what is it? Somebody tell me what decimal that 3 halves is. 1.5. So that means it's greater than what? A is greater than 1, so therefore it's going to be what? Common mistake students make. An improper fraction is greater than 1. Well, Hubert, what are your fractions between 0 and 1? That's easy. Your ring sizes. What's your ring sizes? 7/16, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16. That's your ring size. Proper what? I want y'all to reply when I do something like that. Proper what? The opposite of improper fractions is proper what? Proper fraction. A proper fraction is between 0 and 1. Thank you for the interaction. Y'all suck. Alright. And if you don't know your ring sizes, you suck. Alright? Especially, shut up, Hubert. You're going to offend somebody. They're going to have a cry closet. Alright, let's go to the next. Let's go to the next type. What do you do when you have one like this? F of x is equal to x squared plus 4x plus 4. This is worthless. It's worthless because we want to know what it looks like this. Because this gives us our what? What does A tell us? Direction and what?
Orientation.
Direction and orientation. We just learned that. H tells us a horizontal shift. This is when it's opposite. This is the only time it's opposite in mathematics. Okay, write that down. If H is negative, that means it's going to the right. If H is positive, it's going to the left. If you want me to explain it, tough, because I'm not, because it'll confuse you if I do. It basically is along the H plus X plus H. If it's negative, that means you're doing a negative, so therefore it's going to the left. Okay, I'm not going to get into that, but just remember, if it's negative, you're going to the right. If it's positive, you're going to the left. If H is the horizontal shift and A is the orientation, what do you think K is? What's the opposite of horizontal shift? Y'all are gifted and talented. Vertical shift. Vertical shift means positive, up, negative, down. But in order to get it in this form, what do we have to do? We have to use completing the square. And completing the square gives us that formation. It also gives us the vertex. Vertex and x-intercepts. So completing the square is something that I'm going to teach you and drill it in your head and beat you over the head with it until you know how to do it. Why? Because you can't pass calculus unless you know how to complete the square. Or you could change your major to underwater firefighting and avoid all the math and all the science and then not have a job when you get out of college. Whichever one you want to do. Everybody need a stuffed animal? Everybody good? Okay. Didn't know if you needed a puppy or anything. So, let's go and let's talk about completing the square. First thing you do is you move C. Second thing you do is you add blanks. Third thing you do, and the most important thing, so that means I'm going to write it in red. Okay, I've got to go over this. I've got to ask y'all this because, like I said, 110, 111, y'all's sister courses, y'all about the same material. Have I covered this with y'all? Pendleton, have I covered this? Completing the square. Okay. All right, so completing the square, b over 2 raised second power. 4, back to black, AC/DC, great song. 4, I'm going to have shortcut number 1 or 2 on the left-hand side. 5, find your vertex. And 6, solve for x. Oh, yeah, up here, put a 0, step 0, set equal to 0. Why? Why do you have to set y equal to 0? Because what are you finding? If you set y equal to 0, you're finding your... If you set y equal to 0, you're finding your...
Y.
Your x-intercepts. If you set x equal to 0, you're finding your... You need to write that down since none of y'all answered it. Say, we... Okay. I will make you get a puppy before the end of the semester.
I'm done.
Or a stuffed animal. Or a daisy. Why, Johnny Ringo? Looks like somebody just walked over your grave. Huh? Oh, it's not with you, Holiday. Oh, I beg to differ. We never finished the game we started. All right, so I'm going to, some of y'all have no idea what I'm talking about, and it's your parents' fault. That movie would have sucked if it wouldn't have been for Val Kilmer. Val Kilmer made that movie. Why, Johnny Ringo? Like just walked up your grave. All right, x squared plus 4x plus 4 is equal to 0. Now this is the part I love. I tell students, move C. And guess what the first question they ask is?
Move C.
Move it where? Well, what side of the equal sign is it on? Which side of the equal sign is it on?
Left.
It's on the left. So where is the only place in the world that you can move it if I tell you to move C?
Forward.
To the right. Just a miracle. X squared plus 4x plus blank is equal to negative 4 plus blank. And notice I add the blanks. Now, there's several ways to teach completing the square. You think I'm going to pick the most difficult and confusing or the easiest? I'm going to pick the easiest. I've tried to show different ways over 20 years. This is the best way to show it. It's very methodical. It's very step by step, and students understanding. Okay. If I subtract, if I want to get rid of positive 4, what do? I subtract. If I do it on one side, I got to what? Do it on the other. If I add a blank on one side, I have to what? Do it on the other. Now, 3. B divided by 2 and squared. So what's B? Huh?
4.
Okay, all I heard was 4 divided by 2 and squared is equal to what? 4. And you put that 4 there, and if I put it there, I got to put it what? Over here. So I'm going to highlight this 4 right here. Yellow. I'm going to highlight that 4 yellow, and I'm going to put it right here and right there. Now, what will that give me on the left-hand side of the equal sign? Shortcut number what? 1 or shortcut number what? 2. What do I have? Shortcut number 1, Hubert. That's right, class. So I'm going to highlight, I'm going to circle this red, and I'm going to put shortcut number 1 because of what? Because of that plus. It's either going to be shortcut number 1 or shortcut number 2. There is no other. That's why you complete the square, to make it a shortcut. Everybody understand? You do number 3 over there, so you can get shortcut number 1 or shortcut number 2. And that's going to give us x plus 2 quantity squared is equal to 0. And at this point, you have several things. So I'm just going to, I'm going to erase this and go to the next page, and we're going to continue. So you might want to keep going on your sheet. Don't flip over unless you're running out of room. So x plus 2 is equal to 0. So I'm going to go over to the next page. X plus 2 quantity squared is equal to 0. Now I can rewrite this, and I'm just going to, for your information, I'm going to put an f of x in front of it, and I'm going to say x plus 2 quantity squared minus 0. I brought the 0 over. If that was a 2 or a 5, I'd bring it back over and it'd become a negative. See what I'm saying? This is called intercept form. Sometimes your book or your test or your homework will ask for intercept form. And what is that? Well, what's here? A. What is this? H. And what is this? K. That's your A. That's your H. That's your K. So you need to write that to the side and put test, homework, other classes. You may be asked to put it in intercept form. Sometimes it's called general form of a quadratic. Now, what do I do next? Well, there's 2 directions you can go. One is to find your vertex. I'm going to draw 2 arrows right here. Vertex. Vertex is always the opposite number. And I love it when I say that because everybody says, what number? How many numbers are in that sentence? I'm not counting the exponent. The exponent's not a number. How many numbers do we have in that sentence? 2, Hubert. That's right. What are the 2? What are the 2 numbers that are represented in that sentence? 2 and what? 0. This spot right here and this spot right here. So you take the opposite of both of those. Now, of course, the opposite of 0 is 0. It's not negative. But if that was a positive 4, you would write down negative 4. Okay, so I'm going to take the opposite of both. I'm going to take negative 2, comma, negative 0. And I'm going to highlight that negative because I know there's no such thing as negative 0. But what I'm trying to show you is when you find the vertex in this form right here, you take the opposite of this number and you take the opposite of this number, whatever it is. And you just found your what?
Vertex.
You just found your vertex. Okay? Now over here, I'm going to write solve for x. So solve this for x. So rewrite it. X plus 2, quantity squared, is equal to 0. Take the square root of both sides. X plus 2 is equal to 0. X is equal to what? And that is your x, what? Intercept. So now I can plot this point. What's my y-intercept? Well, my original equation was what? F of x is equal to x squared plus 4x plus what? There's my y-intercept. So now I've got 2 or 3 points. 1, 2, 3, 4. There's my y-intercept. My x-intercept is 0, negative 2. And that's also my what? My vertex. So that means I've got a parabola. Now, on a scale from 1 to 10, with 1 being the easiest and 10 being the most challenging, this is a number 1. We're going to go through all 10. We're going to go through all levels between now and the end of next week. Let's do nerd. And I have to keep, let me see what time it is, because some of y'all go into convulsions and act, really rude, and start packing up and all that. 10:45, I got a few minutes. So let's go ahead and start another one. I'll be nice. I'll do something really nice. X squared plus 6x minus 4 is equal to 0. I already set it equal to 0 for you. Go ahead and start on it. First thing you do is you move C. Watching the news this morning, my son goes, "Daddy, you're not going to buy me any more Nike shoes, are you?" I said, "Hell to the no." He said, "I thought so." "Will you buy Adidas?" I said, "As long as they don't start acting stupid, I will."
Is that Colin Kaepernick thing?
I don't even know who that is.
Doing that ad campaign.
That was a joke. I know who the sorry piece of crap is, yeah. All right, so x squared plus 6x plus blank is equal to 4 plus blank. Now what? That's not rhetorical. I'm asking y'all to interact with me, please. What next?
You divide 6 by 2.
Which is? 3. And 3 squared is?
9.
So I'm going to add 9 on both sides. So now I get x plus 3, quantity squared, equals 13. So what is my vertex?
Negative.
I heard a negative. I love how y'all are so confident in your answers.
-3.
Negative 3, comma, negative 13. Write that down and put vertex over it. Negative 3, negative 13. Negative 3, negative 13. That's your vertex. Now what? Now the other arrow, put solve for what? Solve for x. No, I don't want you to use a calculator because you don't need a calculator. I'll show you why. X plus 3 is equal to 13. I think I'm Russians. Won't go away. Take the square root of 13. X is equal to the square root of 13 minus 3. Okay, the square root of 9 is 3. Okay, the square root of 16 is 4. 9 to 16 is what? 16 minus 9 is what? 7. Half of 7 is 3.5. 3.5 plus 9 is 12.5. So it's in the middle. So 3.5. X is equal to positive or negative 3.5 minus 3. So if you have $3.50 in your pocket and you pay for something that costs $3, what's left? 50 cents. So that's 1x intercept. 0.5 is 1x intercept. And you owe $3.50. You owe somebody else $3. You owe $6.50. We know our y-intercept is what? Negative 4. So let's see if everything lines up. So that's why we sketch graphs, to see if things line up. Negative 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Our y-intercept is negative 4. 1, 2, 3, 4. We have a x-intercept of 0.5 and a y-intercept of 6, 3, 4, 5, 6, 7. Does it line up? Looks pretty good to me. Now you can find the domain and the range and increasing and decreasing values, which we'll get into when y'all come back Thursday. Now, I still want you to work on Chapter 1 and Chapter 2 work. If you have a question, you can send it, or you can just wait, because I'm covering a lot of material, and it's going to fall into place. By the end of Chapter 2, it's going to all fall into place, okay? So it's kind of like we're filling each other, still filling each other out. By the end of Chapter 2, everybody will be on the same sheet of music, okay? So let me go ahead and call the roll. I'll call the roll of the surrounding campuses first, because they might go into convulsions and I can't do anything. They don't. What time is it? Let me see. It's 10:50, so they're going to be going into convulsions in the next 5 minutes.
All right, go now.
They're not in campus. I don't have a pen. I'm sorry.
How you doing?
All right, today is what? The 3rd? 9/4? I don't keep up with dates either. All right, Pendleton campus, when I call your name, you're welcome to go. All campuses, if you have a question for me, stay after class. Burgess.
Here.
Butler.
It's quiet.
Butler.
Here.
Okay, I couldn't hear you.
For me and
Can.
here.
Did he say here?
Yeah, I'm here.
Okay, you need to speak up. Franklin,
Here.
Griffith, both of you. One of you. Kinley Griffith. Hamby.
Here.
Heath.
Here.
McCollum.
Here.
Meredith. JC, I thought I saw you.
Here. And night.
Roach.
Was over here.
Talbert.
It's like here.
And Vickery. All right.
It's like
This is the Anderson campus, 9-4. Brady. Callahan.
Here.
Dean. Floyd.
I'm like search the book where the answer for
Gully.
I'm not reading those things.
Ford. And Ken. This is the Easley campus. Bixler.
Here.
Collins.
Here.
Martin.
Here.
Page, both of you.
Here. Here.
And Terry.
Here.
And the Oconee campus. Lenhart.
Here.
Lusk.
Here.
Speed.
Here.
And Jordan.
Here.
All righty. Y'all keep working on chapter 1 and chapter 2, and I'll see y'all Thursday.
Somewhere else. Let's see if I can mosey on over to end.
Where is my...